Linear equations. Okay, in this video lecture, our objective is we want to solve linear equations in one variable. Okay, we're just going to focus on solving these. They just have one variable to deal with. Let's first remind ourselves what an equation is. An equation is a number sentence that uses the equal sign. Everything on one side of an equal sign has to equal everything on the other side. This allows us to define what a linear equation in one variable is. It's an equation that can be written in the form ax plus b is equal to 0, where a and b are real numbers, and a cannot equal 0. If a is equal to 0, you have no x term, and therefore it's not a linear equation in the variable x because you don't have an x term. I'll write off to the side here. Here's an example. How about 3x plus 17 equals 5? That's a linear equation. If I subtract 5 from both sides, I'll have 3x plus 12 equals 0. And there you go. I've rewritten this in this form here, where a is 3 and b is 12. Okay, let's compare and contrast equations and expressions, which a lot of people kind of confuse. Equations have an equal sign, and they can therefore be solved. Okay, equations can be solved. Expressions do not have an equal sign. We saw that in a previous video lecture. And so all they can be is simplified. Okay, again, equations can be solved. Expressions can be simplified. So how do we solve a linear equation? Well, we'll take a look at the steps you've probably seen before. Okay. And these are, of course, as necessary. You may not have to do all these steps. Step 4 you should always do, but it depends upon what your equation looks like, and we'll do a couple of examples as to whether or not this step is necessary, etc. Okay, so step 1, we simplify. We simplify the algebraic expressions on each side. And this is generally done by removing grouping symbols, which is your distributive property, and or combining like terms, again, as necessary. Step 2, we separate. We want variable terms on one side and numerical terms on the other side of the equal sign, again, as necessary. Step 3, we then solve. We want to get the unknown by itself. We want one of the unknown. And then again, step 4, we should always check our solution. You should never be asking, am I right? Because your solution, you can put back into the original equation, and you're right if it works. So it's never a am I right question. You either say I am right, or you say I'm wrong, but I don't know what I did wrong. Those are the two things you can do with equations as you finish. So let's take a look here. Example 1. Solve 4x plus 5 equals 29. Step 1, simplify. Well, left side has a variable term and a constant term. There are no parentheses here. There's no way to combine like terms, so it's as simple as it gets. Right side is just a number. So it's as simple as it gets. So in this case, step 1, simplify, nothing you can do. Step 2, separate. Variables terms on one side of the equal sign, constant terms or number terms on the other. Well, here we go. I have one variable term, the 4x. I can move this constant term or this numerical term to the right. So I'll subtract 5 from both sides. Remember, with an equation, as long as you do the same thing to both sides, you haven't changed the fact that it's still an equation and you're fine. Okay, so I subtract 5 from both sides. That's a 0. On the left side, I'm left with the 4x's. On the right side, 29 minus 5 is 24. Okay, so now we've separated. You'll notice I have x's on the left in this case, and numbers on the right. They've been separated. Step 3 is to solve. Well, to solve for an x, I have 4 of them, so I'll divide both sides by 4 because I want 1x. So 4 divided by 4 is 1. And so I have an x equals 24 divided by 4 is 6. And so here I am. I think that the answer is 6. That when x equals 6, this equation is true. Let's check it. Step 4. Okay, and we'll make use of a calculator. So our equation is 4x plus 5 equals 29. I replace the variable with parentheses. Okay, I think the answer is 6, and this is a question. Is this true? Okay, does the left side equal the right side? Well, you can either pull out a calculator or do the math using your order of operations. 4 times 6 is 24. 24 plus 5 is 29. And 29 equals 29. So we've checked it. We feel good that 6 is the solution to this equation. Okay, a slightly more complicated example here. We'll do example number 2. Okay, solve 6 times the difference, x minus 3, equals 10x plus 10. Okay, so simplify. Well, the right side has a variable term and a number term. They can't be combined. There are no parentheses. The right side is as simple as it gets. The left side, however, is a multiplication problem with parentheses, and we can apply the distributive property. So 6 times x is 6x. 6 times negative 3 is minus 18. And we have just simplified the left side. Okay, we've got rid of that multiplication going on. Now both sides are simplified. Step 2, separate. I would like for my letters to be on one side and my numbers on the other. I always start with the letter. I like to keep my variable terms positive. If I move the x's to the left, I'll wind up with negative x's, and I'm not a fan. People lose negatives. So I'm going to choose instead to move my x's to the right, because I like to keep them positive. Okay, I've chosen to move the x term to the right, so I need to move the number term to the left. So I'll subtract 10 from both sides. And I have 4x is equal to, well, negative 18 minus 10 is negative 28. There we go. I have just separated. Okay, I got my x's on, in this case, on the right, my number on the left. Now step 3, let's right up here, let's solve. I solve for 1x by dividing both sides by 4. Because 4 divided by 4 is a 1. And I have x is equal to negative 7. Or so I think. Okay. Always check. Okay, so we're going to put negative 7. We're going to take our original equation. And again, I like to replace my x's with parentheses. And then I put in what I think the answer is. Okay, so this is the question. Is this a true statement? When x is negative 7, does this side equal this side? Well, the right side is, well, let's do the math here. Negative 7 minus 3 is negative 10. So this is 6 times negative 10. And again, you could pull a calculator out if you wanted to. 10 times negative 7 is negative 70 plus 10. Well, 6 times negative 10 is negative 60. Negative 70 plus 10 is negative 60. Again, that was the question. Those two things are the same. And there you have it. I've checked my answer, and I feel good about the fact that this equation is solved when x is equal to -7. Okay, so these are the steps. Simplify, again, as necessary. Separate, again, as necessary. Solve, and then always check to see if you're right.